And just in case anybody has really low quality video right now, YouTube is defaulting to lower quality video. In the lower right, you can click the little gear for the settings and change the quality up to 720 or 1080, and you should be able to see everything just fine.
Hey guys, welcome to our first LabVIEW Live premiere. Um, I am Jeremy Marquis. I work at G Systems. I've used LabVIEW for 25 years. I'm a certified LabVIEW architect, certified instructor, and a LabVIEW champion. I see a bunch of people in the chat that I know and love, and a bunch of new people from around the world. It's fantastic that we can still get together. Um, that's actually one of the things I love most about my job is I love getting to get the community together. I hope that you have seen me at the fantastic Certified LabVIEW Architect Summit. Um, or the annual Lava Barbecue every year at NI Week in Austin. I'm organizing a new event, GDevCon North America. There's a team of us that are bringing the Europe experience to the US. That'll be in October this year. And of course, I've been involved with the Dallas LabVIEW user group for several years now. And that has evolved into the presentation that you're seeing now, LabVIEW Live. And that is hosted by G Systems, which is where I work as a engineering technical lead. Since we have so many new people, I want to give a quick introduction to G Systems, since we have so many people that may not know who we are. We are turnkey system integrators. We focus on test and measurement. Industries that we work in include aerospace, defense, energy, RF test, biomedical, and we do design and build for turnkey test systems from start to finish. We provide technical services for software and hardware needs like development, upgrades, repair, consulting and training, and we also support production and assembly capability. Especially during the stay-at-home orders, we do a lot of we serve a lot of essential industries, and so our team is still working. If you have any issues with the number of people that you have available to work, then let us know, and we can try and support you. So right into it. So how this is going to work. So this is a new format for us. We do plan on live streaming our local user groups from now on. So even when we get back to in-person events, we will have cameras and arrays of microphones around the room, so that we can share this with everyone. And one of the key things here for any event like this going virtual is interaction with each other. I specifically did not choose a webinar format because I wanted you all to be able to chat amongst yourselves and chat with each other, because that's really one of the key things that the user group is all about. So I'm going to pass it over to Derek. Derek is a local Dallas guy. He coincidentally won our LabVIEW Coding Challenge 2 months ago. It was some stiff competition, and he squeaked out a win. And I really have to thank him for. Oh yeah, there's his medal. And really have to thank him for his expertise on setting up this live stream. His previous experience allowed us to go virtual without even changing our schedule. We didn't have to miss or postpone a single meeting. All right, so I'm going to turn it over to Derek.
Hello, everybody. I'm Derek. I am a once upon a time CLA. I now work for a company where the certifications don't matter as much, and I'm terrible at keeping up with my education points for attending things like CLA summits and presenting at an I Week and all of that. So today we're going to be talking about a library I developed for doing dynamic user interfaces, and particularly custom arrays that allow you to mix indicators and controls in LabVIEW, which is generally not possible. But before that, there is a pretty big announcement coming out from National Instruments. It's a little bit delayed, so in this video we're about to watch, he is going to say you can download it now. Unfortunately, you can't download it now. But they are releasing a free version of LabVIEW for home and non-commercial use. So here to give us a little introduction to that is Darren Nadinger, talking about LabVIEW Community Edition.
Howdy, y'all. I'm Darren Nadinger, the 7-time undefeated world's fastest LabVIEW programmer. I'm sitting in my home office where I store school supplies, play the piano, and of course program LabVIEW, but not all at the same time. Today I'm in my home, so I can tell you how you can have LabVIEW for free in your home. For the first time, the software that powers the most advanced test and measurement applications is available free for non-commercial use with the release of LabVIEW Community Edition. In case you didn't know, LabVIEW is the world's most advanced graphical programming language, used by hundreds of thousands of engineers and scientists every day. SpaceX uses LabVIEW, CERN uses LabVIEW. Even the Burj Khalifa, the world's tallest building, uses LabVIEW. But in addition to empowering complex applications, the intuitive nature of graphical programming makes it the perfect fit for your personal home projects as well. And with additional support for low-cost devices like the Raspberry Pi and BeagleBoard, LabVIEW's seamless hardware integration makes it easier than ever to get started. LabVIEW Community Edition provides exactly the same functionality as the professional versions of LabVIEW and LabVIEW NXG, which means you'll have access to the entire collection of core LabVIEW tools and libraries out of the box. So if you're ready to get started programming your home projects and have a lot of fun while you're at it, download the free LabVIEW Community Edition today.
All right, so thanks, Darren Nattinger, for that introduction. Here is my little home workspace. I've got a Raspberry Pi hiding here. I've got another older one down here. A bunch of microcontrollers, sonar sensors, GPS and IMU set up over here. I have been playing with Community Edition and the Links Toolkit in beta access, and it is absolutely amazing to be able to use LabVIEW to work with things like Arduinos, other microcontroller prototyping boards, and Raspberry Pis. So, as Jeremy said, I do live streaming. I have been doing it for quite a while, and I'll be doing a lot more of this open source development that I've been doing with Community Edition, additionally with the Links Toolkit and some robotics projects I've got lined up, which you can find a couple of links in the description below. I'll post to LinkedIn sometimes if you're interested in joining me for that. But for now, let's go ahead and get into some demos of what I'll be working with. So there are already a number of UI libraries and frameworks out there already, so why did I have to make yet another one? I've got these demos which let you do things that you've seen other people do before: create clones of UIs, create many instances. So that's nothing new just yet. Another part of the base part of this library is working with subpanels, so you can shuffle stuff around, pop things out, pop them in, everything moves around, and it's nice and clean. But what really makes this framework shine is doing custom arrays. So here is a little demo application I made for a game I've been playing called Good Company, where you have to set up these production chains, and trying to trace back how many of the core ingredients each device that you build makes can be difficult. So of course, being the nerd that I am, I made a program to do it for me. So we can go ahead and create a blueprint here where I'm going to specify what modules from the game this needs. So this is going to be one of the first items you make in the game, is a simple calculator. I'm going to add a couple of items to it. And so now I've got all of these showing up in these what look like arrays. And I can go ahead and scroll with the mouse wheel. I can scroll with the scroll bar. These mix controls and indicators. So for some of these devices that have multiple crafting locations, I can change where I'm going to decide to craft them, and I can see things like crafting times, updating. If I want to see just the direct components that this blueprint needs, I've got a nested array view here as well. So we'll go ahead and create a second one. This is going to be a pocket computer that you make in the third level of the game. And we're just going to go ahead and add a couple of extra components to this. And so now we've got these views which are dynamically sizing to their contents, and I can go ahead and expand that. And now all of these have updated over here. We've got some new items like the register array. Some of the things that were already used have increased their quantities that they're going to need. And we can see the top level blueprints listed up here. And then the last little bit of functionality I'm going to show off is this temperature recipe editor. So I've got this little prompt here that can show you, you can pick from a couple of different step types. So I'll go ahead and just set up a couple of steps. I've given them some nice bright backgrounds so that you can see the difference between the different step types. So we've got just a linear ramp. We have, not 0.3. We've got a step ramp. So every 5 minutes, let's go up 5 degrees. So now you can see it's a more jagged list. We can do a hold for, like, let's say 4 hours. And I'm just trying to add a number of steps to get it to need to scroll. And a cooldown. So here we can see we get a preview of this, which is really nice when you're trying to predict how long the total recipe will take. You can see this is going to take just shy of 16 hours, and you can get an actual profile preview. So don't see any questions coming up in chat. So at any point, if you have any questions about what I'm showing off, feel free to ask them in chat. Jeremy can come into my, let me know if I'm missing any questions or things like that. So if I don't get to them right away, rest assured that Jeremy or someone will let me know that I'm missing questions. Okay, so now that I've shown off the functionality, let's take a look at how it is implemented. I'm going to go ahead and close all of these down. This was actually one of the trickiest parts of developing this framework, was getting everything to shut down cleanly. And I can talk about some of the difficulties in that as we're going through the code. So we've got this object-oriented panel library. I do have this on GitHub. Right now it is only available in LabVIEW 2020. For some reason it's complaining about some of the events when it's trying to backsave to an earlier version of LabVIEW. So I'm still working on getting it backsaved, so you might be able to use it in other versions of LabVIEW and for work, because I highly doubt many people are using the latest version of LabVIEW right away for production code. But so here in our library we've got 4 classes. The 2 we'll talk about first is manager and panel. These form the basis of just allowing panels to be moved around into subpanels and as pop-up windows. The panel defines this dynamic dispatch user interface panel here in this base library. This does nothing. This is just here to be used so that in our, I'm going to have to close down these other guys so I can open the properties, just so I can go into item settings and specify that it needs to be overridden. There are a couple of other properties that are used for managing internal state and allowing any derived children to get initialized properly. One of the things I do use in this is I do use a by reference implementation. So here in our class private data, instead of having things like the state enumeration and other state variables, I've just got a DVR, and then, which is data value reference, and then in our constructor function I generate a DVR and put that into the class instead. So now I can branch the class wire and still work on the same data in multiple locations. It accomplishes the same thing that something like Actor Framework allows you to do. It does it in a slightly less safe way. Well, probably a lot more of a less safe way. But it allows you a lot more flexibility in how your different processes can communicate with each other. And that's how I'm doing things like being able to, from a top-level VI, spawn a panel UI that then runs in the background and can manage its state while being accessible from the top-level application. The other classes, we have this manager class, and this has all of the VIs for creating and interacting and changing state of different panels. So you can do things like put a panel into a subpanel. You can pop out a subpanel, which will take it, whatever's in a subpanel, it'll pop it out and make it a pop-up window. If you have a subpanel reference, but you don't know which panel is in it right away, you can ask the library which panel is in a subpanel, if there are any. So that's the main way to interact with the panels. So we'll take a look at some of those examples a little bit more in depth. So in this first demo, which just lets me create a handful of clones of the same UI, we're just initializing our panel manager instance. Okay, so yeah, a bunch of people are talking about the video quality in chat. YouTube does default to a low resolution these days because of how many people are staying home and using YouTube at once all day long. So if you click on the gear icon in the lower right of the video, you'll be able to manually re-increase that resolution. So when I click the new clone button, so I've got this class type here, which is this cloned panel, and all it does is specify that UI panel VI. And then every time I click the new clone button, I just tell the panel manager, hey, make another instance of this for me. And then when I click show all, we get all the panels, iterate all of them, and tell them to be visible. What kind of error handling do you have for cases where the VI you want to insert into a panel is already open? So it handles that. When we look at the second demo a little bit closer, we'll see that happening, Mike. The panel manager internally keeps track of whether something's already open, and it'll close it and then insert it, or if it's in a different subpanel, it'll remove it, insert it. It does all of that shuffling around for you. So all you have to do is tell it where to put something, and it'll get it there. Same thing for hide all. We just iterate over all of the current panels and make them invisible. And close all is we just get all of them and then close them. And then when they get closed, they get cleaned up. No, that's not the right one. So that's just a basic one showing how you can create multiple clones of a very simple UI. When we look at the actual UI panel, there are a couple of things that have to happen in these UI panels to get them to work with the library correctly. So one of the problems you can run into when you're doing something like this is if you don't wait for your background launched VI to register for its close event, your application could try shutting down and sending that event, and your asynchronous background VI isn't listening for that yet. So it'll just keep running in the background, and you'll lose access to it. And when you go to close LabVIEW, it'll say, hey, there's still stuff running in the background. Are you sure you want to close? So one of the things we have is we've got some handshaking that we do back with the panel manager, so it knows when we've actually started running and are ready to receive a close event, and it can wait to execute later code until that registration happens. And then when we're shutting down, we're going to signal back that yes, we did successfully shut down cleanly. And I should probably actually do that. So let's see. So this is just a simple helper UI that does both the handshaking of the running state and the registration for the event at once. And since this is happening in the in-place element structure with the dereferenced DVR, this will all get updated simultaneously when we exit this in-place element structure. So the calling code that's waiting for this VI to become running won't see that running is set to true until this VI is pretty much done running. And then we can use that event to receive the close event, and we can do stuff like hide the close the front panel, stop the execution of the loop. Otherwise, in our timeout case, we're just counting iterations. Another neat little helper I have is this Timeout Helper. So we've got another event that's part of this framework, which is visibility, and this will return a handful of states. So we've got idle, closed, hidden, visible, and subpanel. So visible is a normal pop-up window. Subpanel is it's in a subpanel. And so we can change whether we have an infinite timeout, so no timeout, or we can specify a different timeout when our UI is visible. So if we've got a bunch of UIs running in this array, we've got 10, 20 more items. We don't want them all trying to update indicators, graphs, anything else they might have in them if they're not even visible. So we can accomplish that with this little guy right here. Future point in your presentation, but which bits of this are library versus specific implementing class panel code? So right now, I'll get into that when I talk about the temperature recipe editor. I think it'll be a little bit clearer when we get to that. So basically, in this example, this is, for this guy, this was application code, and this is application code. So anything that's not in this library is the stuff you would write to use this. If I think I understood that question correctly. So let's go ahead and take a look at the second demo. So this one, we have two panels. I've got two different panel types. I've got one with a green background, one with a yellow background. That's the only real difference between them. I can pop them out and then pop them in. And it closed that pop-up window, pulled out the yellow background instance, and then inserted the green one. And it did that all because it keeps track of the state of all of the panel instances. I can go ahead and close them. So this one, we have two different panel instances that we're setting up. We've got one that we're just setting a green color, and we're just putting this right under the class. We're not changing this at all during the class runtime, so we don't have to put it in a DVR or anything. I just wrote this example just to have different colors. So we've still got a single panel manager instance. We're creating an instance of one with a green background, creating an instance of one with a yellow background, and I've got references to my two subpanels. And then for each of these buttons, I've got the A buttons over here, the B buttons on the right, and I've got events for each of those buttons. So for instance, if I hit the green on the A side, it tells the panel manager instance, hey, I want to put my green panel into my A subpanel. And if we go to B, same thing. I'm just telling it to insert it into the other subpanel. Same thing with the yellow. Pop out, we just say, hey, panel manager, whatever panel is in subpanel A right now, just go ahead and make that a proper pop-up window. And then if we're closing, we're going to get the panel instance that's currently stored in that subpanel or displayed in that subpanel, and then we're going to tell that instance to close down. So again, pretty simple. So we looked at this property already where we're just setting a background color for the panel. In our panel, we're using that to call the color property node on the pane. We're doing our same event registration and handshaking. Everything else is exactly the same. It's just that now we're setting a background color just so we have a little bit of difference. Yeah, so Jeremy's talking about that panel timeout helper that I was talking about. So those are the basic demos just to kind of show off the base functionality. I do have this array example. So this is generating 50 instances, and it's iterating between an A type and a B type. We can see we have mixed indicators and controls. And if I toggle these guys here, you can see it updating here. This is doing it in a not super efficient manner. It's just iterating over every instance, casting it to the intermediate class type, and pulling out a string representation of its current value. But here's just the basic example I set up to test all the array functionality and all that working. A little less interesting than the other demo I have, so we'll go ahead and take a look at that. Let's go with the temperature recipe editor. Are most people using virtual machines for the LabVIEW development environments? I know I do. I mean, I actually haven't run into too many other people that do, and of course, everybody, feel free to answer for yourselves in chat. But I've had issues in the past with trying to run different versions of driver libraries, different versions of LabVIEW, trying to get something uninstalled and reinstalled cleanly. I have some horror stories for that. So now I do everything in virtual machine. If I need to set up a different version of LabVIEW with a different set of drivers, I can do that. When I'm done working on that project, it goes off onto my backup external hard drive, and if in 2 years down the road a client calls back up, pull it off the hard drive. I've got the same exact environment. I don't have to worry about compatibility issues or anything like that, and I can get back to work, and it's really nice to do. Okay, so for this temperature recipe, I implemented this a little bit more as an MVC type architecture. So I've got two libraries here that are part of the application. My object-oriented panel libraries down here in dependencies. So both of these are part of the application code. And I've got the data class instances down here, and then all of the UI stuff is up in the editor library. So I've got a recipe that is implemented in my by reference, well, not mine, but in a by reference style. And it keeps track of an array of the temperature steps. I've got some extra stuff in here to start writing the actual execution engine that's not used right now, but you'll be able to run it, pause it, things like that once you have the recipe implemented. Does anyone know if you have to pay a Windows license fee for each VM or just for each PC? So I have an MSDN account through work that gives for MSDN developers, you get 5 licenses that you get to use as part of your MSDN account. Yeah, so it looks like there's a bunch of people that either use virtual machines or are recommending it, which is awesome to see. So the recipe has some functions to add steps, and I don't think I didn't implement the remove step yet, but you can add the step. We're just getting into our DVR instance, and we're going to append the additional step into our step array. I've got some functions, so like if we read in this data type from a file, whether we get that from an INI file or a binary file, it will go ahead and it uses the factory pattern to retrieve the step type name, and it will create it'll load up the class type as long as it's available in the application, initialize the step, and then it goes ahead and adds it to the new recipe that's being created. If at any point it finds, pretty much the only reason that this would error out is if there is a step type listed that the application that was developed doesn't exist in that application. So we're going to go ahead and clean anything up that we did successfully load, and we're going to ferry that error out. I don't use scripting, Mike, but I do have some code snippets that I've got in my block diagram palettes. We'll take a look at that in a little bit. And then I've got some So I've actually got the timing stuff implemented for all the start, stop, pause. And the way this is going to get implemented is basically it just keeps track of start times and any accumulated pause time. And it will just know which step to ask for. Hey, give me the temperature you would be set at this specific time into your step. But what I do have done here, I finished up at like 1:30, 2:30 Sunday morning, so I didn't feel like touching it the rest of the way after that. Then we have our step base class. This is also by reference because we need to access this potentially multiple places. We have our user interface panels that are going to be allowing us to edit parameters of this step, as well as the base step actually stores all of the parameters as string key value pairs. So that way our derived step types don't really have to keep track of much themselves. In fact, they're completely empty. The specific step types track no state. They do all of that via the parent class methods. They just know what keys should be available and how to display and render them. So we've got a couple of, I'm going to call them abstract methods down here for some of the different features that or functions a step should implement, such as generating plot data for that preview graph, and to show Mike the DVR stuff. So I've got this snippets folder down here that I've added, and I've got a biref parallel read. So now it is exactly the same number of clicks to use a DVR as it is to just plop down and unbundle by name, wire it up, and pick your member. And I've got a couple of different kinds. So I've got for parallel reads, writes, in-place updates, so if I needed to change something there, I can. And then I've also got another snippet for launching background VIs asynchronously. So just a couple of things that make most of the stuff I do much quicker. Another neat trick I have, I'll show this off quick. By the way, the developers of LabVIEW 2020, I love the new class interface stuff. Yeah, we'll just name this class 1. Right when you're creating a class, you get to immediately pick the parent. You get to pick any interfaces if you're using interfaces, and it will save it right away instead of putting it into your project unsaved. You have to go into the properties and parent it, all that stuff. This is already saved. It already exists on disk. Another tool I have is I've got some scripting for doing folder layouts that I do commonly in my classes. Yeah, DNAT, y'all are sending it out of the park with this 2020. If only in the beta you could create classes and libraries, but I'll wait till the full version to be able to do that. So that's the basic step implementation. And then we've got specific step types. So these are, well, first let's take a look at the properties. So all of this is done via string representation of their parameters via the parent class. So these operate more or less identical to the INI files like this, except that the only option available is string. And sorry, DNAT, I'm not using much quick drop yet. So I've got some property getters and setters just to make my code a little bit cleaner instead of having to call those parent methods all the time and have all those string types all over the place. And if I'm doing these properties, there are only 2 places that I have to worry about having typos for my parameter names. Another thing you could do is you could use an enumeration that you format into a string. You don't have to worry about typos at all. But this now This is what one of the linear ramp just creates a preview point at the start of the ramp, and another one at the end of the ramp, and then the chart will glue those together. How do you even LabVIEW without Quick Drop? Yeah. Or I actually do LabVIEW with my Wacom tablet quite a bit as well, which is fun. Makes it really feel like I'm drawing schematics. So there is, I think I've got, I think I put a link to my YouTube channel. Yeah, so if you go down in the video description, underneath the video, you'll see a Derek's YouTube channel link. I'll go ahead and paste that in as well. I'm fired. So yeah, so like the soak one is also very simple. We're just creating our start point and then our end point, whatever that duration is later. In the UI panel, well, again, so these base classes, you might want to run this in something like a compact Rio, which is controlling an oven or some such device. So I did this temperature recipe library without any UI stuff in it all. This is basically just the data management and execution steps needed for using it. And then I've got my recipe editor library up here, which if we look at our app, I'm doing some tricks like I'm enumerating all the VIs that are in memory. So as long as I've got a step type defined and then a panel that is that same name that ends in panel defined, my application will automatically find it. So I don't have to remember to go and put it in some array or put it on some block diagram. It will automatically show up as a step type. So when we run it, we get to our editor UI. And here I'm creating, oh, I have to cough a second. Give me a second. So we're creating an instance of our array manager this time. So again, to maintain proper state of the different instances of the elements that you can be putting in your array, everything is done through an array manager instance, which itself uses a panel manager instance, and then it's got a whole bunch of events and stuff that it uses to keep track of things. We're going to get it started running by specifying which subpanel we want it to use for its display, which I actually haven't described that. To use this, all you need is a array manager instance and a subpanel that it will put everything into. So the array manager has it's, I'm going to go ahead and close this base one down. It's got its own panel that it puts in that has a whole bunch of subpanels that are all here, and most of them are going to be hidden, and the scroll bar, so you don't have to worry about laying them out or sizing them or anything. It will size everything appropriately. And then once we move into the array world for this, all of the panels must specify a desired size. That's where they can specify width and or height. Right now this just does vertical layouts. I will be adding some functionality to do horizontal layouts, at which point you'd want to specify a width, but for now most of my panels just specify a height because they're meant to just space themselves out vertically as necessary. So yeah, so we're telling it to start, giving it the subpanel instance we want to use, and then just so I didn't have railroad wires and going across every event in my event structure, I am throwing this into a front panel indicator, which I then use local variables for. Have I thought about supporting a 2D array with tiling or some other arrangement? That sounds like a really fun thing to attempt to implement. I'm going to have to work on that. No, I have not thought about it, to answer your question. We're going to make that happen. So yeah, let's see here. So when we click the add button, we're going to pop up our prompt, which just takes a look at the different step names that are available as part of our class. The panel resize isn't smoothly animated. It instantly displays the panel, or it doesn't. But we'll take a look at that again, and maybe you can get a little bit more specific with your question. Because I'm not sure exactly what you're asking. But so they can just pick one of the types. We return that type. I've got a VI here that takes in that type name, maps it to the array to get the step type and the panel type. Again, we've got this. If you only ever needed everything to be part of your UI application, you could just have one class that is both your user interface editor and has all of the data and stuff in it. But again, I wanted to separate this out so that I could run this without any issues on things like compact Rios, which generally don't have user interface stuff. But here we're finding the type of the class we were told to initialize. We're first creating the step, and then we're creating that step panel and assigning the step into that panel. Then we put that panel into our array manager instance. We'll get back to that in a minute. So what do the step panels look like? We'll start with the soak one because it's really simple. So again, these are just editors for the data class. So these UI panel classes are very, very simple. The only thing they do is display they have the UI panel. We do have an intermediate step panel type. And so all three of these panels that are up here all inherit from step panel. And step panel is what does things like keep track of the step, because every step type is going to have a step. Does the desired size. So I've just got this hard-coded. Everything is going to be 48 pixels tall, which in the default grid settings is 4 of these grid spaces. Keeps track of some ref data for maintaining state. It's got some utility VIs, like anytime this panel has a value get updated, it can call this fire update in the parent. And this was an event that was passed in by our editor class. This update event was passed into our step panels when they're written. And so that's how it can signal back to the application, hey, we've got a change, do whatever you need to do to update. And then in our subpanels, we've got that same register events and handshake the run. We're doing things like initializing our user interface controls and indicators, anything we might have. Because we do have this intermediate step panel type, the step panel type only knows that we have the general idea of a step. So it is our soak panel that knows that it should specifically be working on soak step instances. So we're doing that typecast here. This is ridiculously light on error handling. This is meant mainly as a demo. But once we cast it to the soak type, we can then know that we have access to the soak steps duration parameter. And all the time is stored in seconds, but in our user interface, we're editing this in hours. So we're just doing that little bit of math here. Anytime our duration changes, we re-update that parameter on our soak step instance, and then we say, okay, go ahead and update by firing that event. And when we close, we just shut down, clean up our event registrations, handshake back that we're done shutting down. And so all of the steps are going to look pretty identical to that. Some of them have 2 or 3 parameters, so they'll have a couple of more events based on what the step is, maybe doing some math to convert time units. But this is an example of what is all of the application developed code that uses this. As we could see in some of these examples, you don't have to implement your classes as by reference to use this. If you're only putting things in your class, so if you only have things that are either reference types themselves, like queues, notifiers, events, things that you can branch the wire on and still have access to the same event or queue or whatever, you don't necessarily need to follow a by reference implementation. There are some protected methods like constructor and cleanup functions that you can use if you do need to set some of that stuff up, but it doesn't necessarily need to. This isn't directly compatible with a framework like Actor Framework. You could use this array view on one of your actors UI panels, but you couldn't use these as actors directly. I personally don't use Actor Framework, so I have no desire to figure that one out. So I think that's pretty much it. Oh yeah, and then we have oh yeah, we looked at the preview. So the panels are pretty similar with minor changes. Is the reason you didn't put more functionality in the intermediate parent because so much is driven from event structures. So you can't have shared user interface. Like you can't, there can only exist one VI instance that you actually open and display. So I couldn't have in my parent class, I couldn't have a panel here and then also define a UI panel here. I can only pick one UI panel. If you really wanted to get tricky, you could do some stuff like put a subpanel on here that you then insert another instance of a VI from the parent class. You would have to do that manually. There's no built-in support for that. You can do things like share data types, and we'll see in the blueprint editor how I do share a little bit more functionality. But really, just because of the way LabVIEW runs, we're only getting an instance of one VI clone to display and run. And then with the UI stuff, like you can share. I could have an event structure as part of a VI that I run in parallel in the parent class, but then I would then have to send in references to the front panel controls that I want to change, and that would probably end up being more work than just having what looks to be almost identical VIs. These are all, step types in a temperature recipe editor. They're going to perform similar functionality. The main thing is that it's all it's similar structure. We'll see in some of the other demos how things might look different. And it might be a good idea to talk about how I accomplish this. Now that we've looked at some of the examples, looked at some of the code. So I am faking dynamic dispatch. Wondering if there's some clever way to get the benefits of inheritance even with these constraints. That would be more framework development. I'm sure there could be something done. But for UI stuff, it's pretty limited. If you're just doing method functionality, like if you're doing a recipe execution system for automated testing or things like that, where it's not directly tied to user interface stuff, yeah, that's where you can do call parent method node stuff and define a lot of reusable behavior in parent VIs. But just because this is user interface stuff, it's to my knowledge, it'd be more work to reuse that behavior than it is than just the couple of minutes it takes to plop down an event structure and a couple of indicators. So we will see some blue barred property nodes here However, these are scripting defined property nodes that are accessible in the runtime engine. Yeah, more work for the framework creator, but less work for the rest of us. No, but you'd still have to specify all of the front panel references that you'd have to send in so that you could have like a shared event structure. And like, how do you abstractly define how to handle, like, let's say I put a name in the step. So now I've got a mix of strings and numbers. How do I know how to convert units on a number correctly? There's just, it's nearly identical structure, but there's not too much else to simplify, at least how I'm doing it in these temperature steps. So what I am doing is in my base panel class, I've got this VI, run panel VI, which is community scoped. So the only people, I think only the manager is a friend. Oh, the array manager and the manager can both access these community scoped VIs. So when you tell the manager, hey, here's a panel instance I want you to run, it will then call this run panel VI method. And then this run panel VI method builds the name for what the panel VI should be in memory. And so because this isn't just going to be the base panel, this might be something like linear panel.lv class. We're going to, and whatever library it exists in, we're just going to add in the specific VI we're looking for. We're going to open up a clone of that using the OpenVI reference. And then we're going to do some inspection on its connector pane to figure out what the connection is in the upper left corner. So if we take a look at this panel, this is position number 11 in the connector pane. I believe it runs from top right. It runs from top right. It then runs down and left. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8. No, 8, 9, 10, 11. Yeah, so it circles around in a not intuitive pattern. It was trial and error to figure out which one I needed. But since you would normally be hooking VIs up by where things are on their connector pane, this was the route I went for. In the past, I've looked for things by name. I've done type inspection using some of the variant stuff to where you can get type information. This is just how LabVIEW already is intended to be used, so I went with this route. And this does work in compiled executables, which is nice. Normally when you see the... Ooh, there's a shipping example that gives you the terminal indices of all the connector pane patterns. That is nice. So Chris B is talking about a subpanel enabled actor where each inheriting class had to define something that would insert into the subpanel. So he's doing things a little bit more programmatically. Can you do clones of those, Chris? No, this runs pretty quickly, Cyril. We'll take a look at how it handles scrolling and things like that, and some of the tricks that I did to let it run as smooth as it is. We can go back to the first library. Oh yeah, so by the way, we're going to be shutting down this stream probably here in the next 15 minutes. Well, we're not going to be shutting down the stream. We're going to be doing the ending of the stream and talking about June's topic. But anybody is welcome to stick around for as long as they want, and we can go into more specific questions. I've got a lot to cover here, and I think I'm already kind of past time. What was I looking at? The base library. So in this array example, so here's 50 instances. It starts up unnoticeably quick. I can scroll around nice and fast. Closes down. That's how long it takes to close down. if I start changing this to something like 500 panel instances, it takes a while to now shut down, but initializing and running it are still quite fast. But closing down, we're going to start to notice that it pauses here a bit longer. And that's because it's got to iterate over each one of the instances. It's got to do the handshaking to make sure it shuts down cleanly. So that's really the only slowdown, is when we're doing the cleanup in here, and when it's going over each of those panel instances and making sure they're shut down cleanly. Okay, yeah, thanks for probably making my wordiness a little bit more clearer, Jeremy. So this can work with, at runtime, it runs great with lots of panels. Just if you're trying to create them or close them all at once, you'll notice a hiccup. Oh, wait, let's change this back to 50 so I'm not confused the next time it runs really slowly. Yes, it is. We'll do a deeper dive into shutdown stuff and some of the issues I ran into that when I started doing the blueprint calculator one. But anyway, back to this. So we're getting that pane type. We're figuring out what that item's control name is, so we can then set the value for it. Then we use the run VI. Excuse me. We use the run VI invoke node to run it. We're going to wait for that handshaking signal to come back, and we initialize it to a closed state, so that means that it's running, but it's not displayed or inserted in anything yet. And then it will continue to run. There is also timeouts on these. I was very glad I put that in, because I ended up having some deadlock conditions from nesting some of these displays. And so as I was figuring out everything that needed to be reentrant, I was very happy that there were timeouts. He used queues to avoid having to close references. Each clone check the queue. Yeah, so the way it closes down is it sends an event. Yeah, we'll take a look at that. So I actually did a shared presentation with Viva at NI Week last year. It's a pretty cool dude. He's got some really nice, if you like a very nice framework for like laying out user interfaces and doing some dynamic user interface stuff, he's got a really nice framework for doing that stuff. And then just so lastly, let's go ahead and take a look at the calculator demo quick, because this does some other neat stuff, and it's got some really academic design decisions were made in this. This is not how I would implement this for any production stuff. But we've got our application, and this is also kind of an MVC. I've got base classes that define items, so these are the ingredients that can go into things, and the blueprints themselves are also items. And then the workstations that they can be crafted at. And then these define the properties, such as what other ingredients does that item require, what is its name. This is actually implemented in the parent. We're just stripping off the class name. Nothing's in a library here, so we don't have to worry about stripping off library names. Everything specifies a picture, and that's how everything gets displayed. Because I've actually only got one user interface panel type that can display all of my item types. What stations can be crafted at, and what type of object, or what type of item it is, so whether it's a raw material, component, module, product. I'm not actually using that anywhere yet, but I know some places where I'll use it in the future. So then in the blueprint, this is a by reference item, because this, while we're working on the blueprint, we're going to be adding and removing items on it. We're going to be changing the quantity of items that are on it. So this one I did update as a reference. It also does take in an update event that it can use to signal back to the main application, hey, I've got some changes. Go ahead and recurse all of the ingredients again. We've got some utility functions for adding components, removing components, things that are used in the by the editor. Oh, and now there's a train going by, so hopefully that shouldn't be too loud. So Blueprint defines a couple of other things, like the Blueprint keeps track of its own crafting time. Instead of just having a hard-coded list of ingredients, it keeps track of the ingredients that were added by the user. The product name is specified by the user, so it gets and sets that. So it sets it with this property node, so the user interface can change that. And then when it gets the name, instead of having a hard-coded name or using the base item class's name that derives it from the class name, it uses its specified name. And then we've got some different items that specify the ingredients and quantities that they need. I was still muted. Thanks for stopping in, Mike. You had some really good questions. I'll make sure we answer a couple of your questions once we do our little closeout and we stick around for more Q&A. Specifies a picture. So these are just constants on block diagrams. If I was doing this in real life, I would not make a class instance for each of these types. I would just have a table that, like an array that defines the data for each of the class types, or for the item types. So this is a very academic way of doing it. There is a lot of work in creating all of these property VIs. And there were a couple of times when I was initially developing this where I needed to change what some of them did and what their connector panes looked like. And that was a lot of work going through and updating all of those. So in production, I would just have a table somewhere that lists names, ingredients, pictures, things like that. But we can see that these are all pretty much the same. And then in our main, so our item summary, this is what can take in an item. So we actually use an event to ferry the item into the user interface for this one. I was thinking about trying to reuse panels and not have to close them down and reinitialize a new one, but just nuking all of them every time and making new ones ran plenty fast enough and was way, way easier. Yeah, so whenever we get the item of what we're supposed to be displaying, we do its quantity, pull all of the properties out of the class, get some properties from the station, and just update our user interface. Our raw components don't have stations that they can be crafted at, so their stations array will be empty, so we hide the stuff that isn't applicable to raw materials. So we just clean up the UI a little bit for some of those guys. And then in our Blueprint editor, down here in the app, so this is what the main application, the main editor VI looks like. It's pretty simple. I've got two array manager instances because I've got two arrays. One that displays my Blueprint specific information, and then one that specifies the entire recursed list of ingredients. And when we're adding, we're going to create a new Blueprint. We're going to open up this Blueprint editor. This is where I could add the different components to. And so we're going to prompt for a specific type. Here's a case where I do put them all into an array and then get their name. This is the, if we're not looking through every VI in memory, this is the kind of stuff you typically have to do to support multiple types in applications. But we're just going to let them pick one of those types and return the actual class type out. So if I turn on context out, we can see that that's an item instance. And if they canceled, we don't do anything. If they didn't cancel, we're going to add that component type to our Blueprint. we're going to initialize its quantity to 1, and we're going to initialize the blueprint item panel instance. So this is just where we display a picture of the ingredient, what its name is, and how many are used. And that's what shows up in this list down here. Oh, I didn't want to close it yet. And then basically every time we change something, like we add an item or we change a quantity somewhere, I've got an event that gets triggered. I forget exactly where I did that. But it signals back with an event that the blueprint was updated. And then in here our application stores an array of the blueprint instances for us. Since all of these blueprints are defined basically in the shift register, I didn't do my application as a by reference type because we didn't need to access that in multiple places. And then I've got this VI that uses a queue to pull all of the ingredients out of each type and build arrays, and it does some stuff because things can be made in batches. Something might be made in a batch of 10, but you only need 4. So it's got some other stuff where it handles all of that properly. But because all of that is defined on the base item class, I can add new items, not have to update any of this code, as long as it provides all those properties. And then for each one of those ingredient items that are passed back out, we create an item summary instance via the panel manager, and then we're going to assign that item into that panel. So I think we've got a couple of minutes left for questions right now. I'm going to go ahead and we can go into that shutdown question we had. At this point, if you've got any questions, feel free to ask. I kind of went through a whole bunch of stuff really quickly, so I don't necessarily remember everything I got to or didn't get to. So for an array manager instance, when we're closing down our array manager, the first thing we do is signal to that panel that has all the subpanels and the scroll bar on it. We're going to signal to that to close down. And then in that, when it gets the stop, so we're just closing down. I've got a little bit of a state machine here. We're going to clean up. It's going to clean up all of its references and events that it registered for, and then signal that the background VI is no longer running. So we're going to wait for that to become false here. Once we know that that is closed, we know we can start shutting everything else down. And so we're going to close down the panel manager. So the panel manager also keeps track of the list of panels that it knows has been created. And this way, with things being by reference, if you don't have something that's keeping track of those, it can be easy to forget to keep track of them yourself. So both the array manager and the panel manager keep track of all of the panels that are created through them. And that's why I have it so you have to create panels via one of those two managers. It's going to go through and signal a shutdown. So for each of those panels, it signals a shutdown. So it's going to fire off a close event. In case something uses polling instead of the event mechanism, we also are going to set a flag in the DVR that can be checked by derived code, and we're going to wait for it to signal that it's shutting down. Now, one of the things I could do is I could have, in addition to the panel-specific close event, I could have a global close event, and then that would make things close down a lot faster. We would still want to, This is the main thing we're waiting for here. If we don't wait for that panel to close down cleanly, we can leak all sorts of references. I don't know that there's really any difference between VI accessors or property nodes. I've got mine implemented as properties, so you can use them as either. Just out of habit, I typically use them as their VIs. There are a couple of places where I have used them as property nodes. Where did I do that? Oh, it was on the item summary panel. No, it wasn't. This one. So I do use both from time to time. Generally speaking, I use the VI ones. This is really the main cause of the shutdown slowdown, is we are iterating over all of our panels sequentially, and in turn signaling each one of them one at a time, waiting for it to shut down. Then we're going to the next one. This could definitely be cleaned up better. And something you wouldn't want to use this for is if you're using this to. So I know Aristos Q, AQ, Stephen Loftus Mercer, was working on editors for sets, for the new set data type in the newer versions of LabVIEW. And a set can have, hundreds, thousands of items in it. You would not want a panel instance for each one of those items. This could be implemented as a parallel loop as well. I believe I tried that and didn't notice there wasn't a noticeable difference to the user. Really what I need is just a different mechanism when we're wanting to shut down everything at once. Or what we could do is do this in 2 steps, where in one step we iterate over each panel and fire its shutdown event, so we can tell them all to shut down. Then we check to see if they're shut down, and that should be a lot quicker as well. And I like that better than having a global shutdown for all of them, because you can't have multiple recipients on events generally very nicely. And I don't want to use a polling mechanism like a queue or something else that you would have to periodically check. So I'm still playing with parts of this. Thanks for stopping in, DNAT. It's good to see you. Hopefully we'll see you for some future events as well. But actually, you know what? I should put that. Let me put a to-do note in here. Ah! Okay, so I think we're going to take this opportunity to do our little closeout. We do already have a topic picked out for the next LabVIEW Live event that's going to be happening on June 17th. So there is... I'm going to hand it back over to Jeremy. So I've got Jeremy on mic again. And we're going to go to... There's our information for next month's next events, which is in 2 months stream, and we're going to go ahead and let Jeremy talk about that.
All right. Thank you very much, Derek. That was pretty slick. It's not very often that you get to see somebody present something that applications for it are immediately apparent. So that's extra valuable. Our next session is in, like Derek said, is in June. We're gonna hear from Virgin Orbit and how they leverage System Link to unify their data from LabVIEW and many other sources for their real-time business value. We do have open spots, and now that we have opened it up to nationwide, it's really easy to get speakers from all over, actually worldwide. And so if you have a topic that you would like to share with the community, please message me on LinkedIn, and I will we'll start a conversation and see how we can get it on the schedule. Thanks to everybody, and we will see you next time. You do not have to get off. We can stay on and keep chatting and keep streaming, but this is the end of the official presentation.